In the last video, we had discussed about the ambiguous and unambiguous grammar. The grammar is called as a ambiguous grammar if it produces more than one parse tree for a given input string. When a grammar produces more than one parse tree, then the parser will be in the confusion to make a decision about the correct parse tree. To avoid this confusion, we will rewrite the grammar in such a way that the grammar should produce a single parse tree for a given input string by eliminating the ambiguity present in the grammar. Usually, the grammar has two types of ambiguity. One is a left recursion and another one is a left factoring. Let's see how to eliminate these ambiguity from the given grammar one by one. First, we'll see how to eliminate the immediate left recursion from the given grammar. So what is a left recursion here? The left side of the grammar symbol occur recursively in some of its production. So we will eliminate this left recursion production by rewriting the grammar. To rewrite this, we are going to make use of a formula or some technique we are going to use. Let's see how this technique work on n number of A's production. Assume that this is a grammar production where A is a grammar symbol which producing n number of production. Some of its production begin with the grammar symbol itself, that is A, and some are not begin with the grammar symbol. The production which are begin with a grammar symbol are called as the left recursive production. So we will rewrite the grammar by replacing A's production as A produces beta 1 A dash, where beta 1 is a A's production only which doesn't begin with the A. Then we introduce a new grammar symbol, that is A dash. So first we will consider all beta productions and we will write those beta production along with the new grammar symbol A dash. Then we will write the production of A dash. So what this A dash produce here? The A dash produce alpha 1 A dash. So what is the alpha here? After A, whatever left out in the left recursive production, that is called as a alpha. So alpha 1, alpha 2, alpha n we are going to write along with the new grammar symbol A dash. And at the end we are going to introduce a epsilon symbol. Let's see this by taking the example. Here I had considered a grammar, that is E produces E plus E, E into E, bracket E and ID. So we discussed this grammar in the previous video. As we discussed, the given grammar is the ambiguous grammar because it constructs more than one parse tree for an input string id plus id into id. So what type of ambiguity this grammar has? It has a left recursion. Here E is a grammar symbol which produces 4 production. Among these 4 production, 2 production have a left recursion. So we will remove a left recursion from the grammar by marking beta and alpha and rewriting the grammar by applying the above formula. So here this production has a left recursion. So after this E, whatever comes, that I will mark as a alpha 1. Second production, again it has a left recursion because the left side E symbol occur as a first symbol in the production. So after leaving this symbol, whatever left out, for that I will mark as a alpha 2. And what about these 2 production? These 2 production doesn't have a left recursion. So I will mark these 2 as a beta 1 and beta 2. Then we will rewrite the grammar by using above formula. So what this formula tells? A produces beta 1 A dash. What is there in the place of A in the given grammar? It is E. So I had taken here E. E produces beta 1. What is my beta 1 in this grammar? That is bracket E. So I had taken bracket E along with the new grammar symbol E dash. This is a grammar symbol which I introduced. You can introduce any of the grammar symbol here. Next, I will take a second beta value. So what is the beta 2 here? ID. So ID I had written along with the new grammar symbol. If it has a n number of betas, so write all those n number of betas along with the new grammar symbol. Next, we will write the production for this new grammar symbol E dash. So what this E dash produce? E dash produce alpha along with the new grammar symbol. So what is the alpha in this? So for this we are going to consider the production which has a left recursion. So after leaving a grammar symbol, that is E in this case, whatever left out, that is a alpha 1. So what left out in the first production? Plus E. So I had written plus E along with the new grammar symbol E dash. When I consider the second production, what is my alpha 2? That is into E. So I had written into E along with the new grammar symbol E dash. And at the end I must introduce what? The epsilon. So this ambiguous grammar is rewritten as E produces bracket E dash or ID E dash, and E dash produces plus E dash into E dash or epsilon. Now let's check out whether it produces a single parse tree or a more than one parse tree for a given input string ID plus ID into ID. So here I had written LMD to parse the given input string, that is ID plus ID and into ID. So when I construct a parse tree for this after applying the LMD, so I got this. The RMD and construct the parse tree, you will get the same parse tree. So if you use a LMD or RMD or LMD with RMD, you will get a same parse tree. So this proves that the grammar start producing single parse tree for a given input string. Let's take one more example. Consider the grammar which has 3 productions and 3 grammar symbols. E is a grammar symbol which is producing 3 production. T is a grammar symbol which is producing again 3 production, and F is a grammar symbol which is producing 2 productions. So when I consider the first grammar production which is produced by a grammar symbol E, I come to know that the production which is produced by E has a left recursion. So total it is producing 3 production. Among these 3 production, 2 production have a left recursion because E is a grammar symbol and E is occurred as a first symbol in this production as well as in this production. So I will take this production separately and I will rewrite this by applying the formula which is shown previously. So before I rewrite, I will mark the alpha and beta of the grammar production. So this production has a left recursion. After this E, whatever left out, I will mark it as. When I consider the second production, after E, whatever left out, I will mark it as alpha 2. And the production which doesn't have a left recursion, I will mark it as a beta. So how to rewrite this? First you take a grammar symbol itself, that is E, which produce what? The beta. So what is the beta in this case? T. And then introduce a new grammar symbol. So here I had introduced a new grammar symbol E dash. And what this E dash produce? Alpha 1. What is my alpha 1? Plus T E dash, and alpha 2 is minus T. Along with that I will write the new grammar symbol E dash. At the end I am going to introduce the epsilon symbol. Next, move to the next grammar production which is produced by a grammar symbol T. So again you check out here the production which is produced by a grammar symbol T has a left recursion. So take this separately and remove the left recursion. So after removing the left recursion, what I get? T produces f t dash. T dash produces into f t dash divided by f t dash and epsilon. When I consider the third grammar production, which is produced by a grammar symbol f, so it doesn't have any left recursion because the first symbol in this production is bracket, which is not same as a grammar symbol, and second production has a id. So these two production doesn't have a left recursion. So f is free from the left recursion. So I will write f as it is. So I will rewrite the grammar. In place of E production, I will write these two production. In place of T production, I will write these two productions, and in place of F production, the F production is written as it is. So at the end, after removing the left recursion, these are the grammar production that I get. Thank you.